Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to these slides. Now we were discussing about analytics, and in industry, since the industry is continuously operating, so with the passage of time, the industrial data increases with the time, and also that also increases the interdependence between the various signals. Uh, interdependencies between variables, various signals or variables, it also increases. Okay, so as the industrial data increases, the interdependence between the different various signals also increases. So the simple analytics cannot be very helpful. So what we need is we need multi-layer layers of analytics. And thus the whole thing becomes like the complexity increases. Okay, we will start for one by one. So initially we will talk about the basic analytics, basic analytics, and then this basic analytics will be improved, and we will talk about the advanced analytics. But this is all needed. You cannot deny this. So the basic analytics is basically your first layer, and this first layer is typically used for descriptive diagnostic and descriptive diagnostic and also short term. It is important to understand short term predictions. We will see why we are calling it short term predictions, because it is based on simple rules, and we cannot exactly can't generalize for all cases, for all future, and it will fail at certain time. In diagnostic, we see what has happened, uh, why happened, and in descriptive, we talk about what happened. In diagnostic, we talk about why it happened. This is answers the what, and this answers why. Okay, so the idea is straightforward. We have signals which are continuously monitored, and for example, this signal, and we have threshold, two threshold, high and low threshold, and when the signal crosses that certain threshold, we have a alert 1 at 1 a.m. And then again, this threshold happens, it crosses the threshold at 1 uh, 1 after 1 a.m. after 1 minute, and then this threshold is after 2 minutes. Okay, so whenever the threshold is crossed, we have an alert generated. So indicating what is this indicating? This is indicating unusual behavior. Okay, so what we can say is these are like rule-based detections, and the benefit is these simple rule-based analysis. What they are simple, and they are fast, and they are effective for early mornings, for early warnings. Okay. uh, but there is another problem, but can't but they can't capture the complex or complex relationships or deeper causes. And that's why we talk about, and that is why we we use an advanced analytics. Okay, we will explore in the next few slides. So we will continue with the basic analytics. So now, although the basic analytics is rule based, uh, and it is simple and appears simple, okay, but we have to be very careful when design. Okay, so designing, in simple terms, I should say that uh, designing something simple is not easy. Okay, this is very important thing, and we have to deal with the complexity. We have to deal with complexity to bring simple solutions work for us. Okay. So one challenge is avoiding the repeated alerts, for example, in this games. So sometimes what happens is anything can happen, and due to the noise or the oscillation in the signal, it may trigger false alarm or event. Okay, because of, and there might be sometimes it is noise or something like that, or oscillation near the or noise or oscillation near threshold, and we don't know why this noise or bias is there, and there may be some logical reason for that. So that means we need to tune the threshold dynamically. And so the tuning of threshold dynamically, this is very important, and it depends on past data and events, and also on like user feedback. Okay, so these two things are important, and because of this, what happens is we are going to get, we are going to get two things. Number one, we will get the improved uh, accuracy, and also we will get uh, we will somehow reduce unnecessary alerts. Okay. Next, from the IIoT implementation point of view, there are so many commercial tools available. For example, this OSI Pi. This OSI Pi is usually used for real-time data infrastructures, uh, for real-time data structures, for real-time data structures, and infrastructures. And this Predix APM is from GE, and this offers asset performance measurement management. And then we have Azure PI integrator. This is another solution for integrating the time series or analytics in the workflow. So this helps to integrate analytics in IIoT workflow. And the good thing is these can be installed on the edges, on the edge or on the cloud. The so the good thing is, let me write it here, that the even the basic analytics, uh, if implemented professionally, it is like it provides like a solid foundation analytics. Okay. Okay. Next, we will see about advanced analytics. So moving beyond the basic is the second is the advanced analytics, and in advanced analytics, typically there are two things in which we talk about, and we take it as a advanced analytics. One thing is about prediction, and the other thing is about prognosis. And the goal here is not just to detect the anomalies, but to forecast the future events. And what are the future events that we have to, if we know, then we can add the value. So the future important events that we want to know is, for example, some kind of a possible failure, or there can be some kind of like a performance drop, okay, or some kind of like maintenance needs, okay. So in future, if I know my car or anything else or plant, they need some what kind of maintenance is needed, or probability of failure before it happens. But in order to do that, what we need more information. Okay, we need more information, and also plus in addition to that, we also need uh, the model. We need the model of the whatever you call the asset or system. Okay, and it's all operating data. So what we are talking about is, what we need sort of like digital twin, and we also need some past data along with the current data. Okay, we also need data, past data, and also the current data. Okay, So this will help us, and this digital twin will learn based on um, on the data and behavior of asset or system, right? So these analytics integrate the results from the basic analysis to more complex models to get the deeper insights. Okay, so advanced analytics help us to get deeper insights. And there are a lot of different technologies which are used for the analysis. Different type of R, Python is common, Scala, MATLAB, and others. So in short, what happens is the advanced analytics, it actually brings AI, machine learning, and simulation together. Okay, so it combines all of them, and everything has its own benefit. And what happens is adding these things will bring us like uh, these things will help smart decisions. Okay, so the main outcome of advanced analytics is we are able to make the right and the correct and smart decisions, right? Okay, continuing with the advanced analytics, here we are showing the advanced analytics in the concept of digital twin. A digital twin is basically a virtual replica of a physical object, like any machine component, or even this can be your any machine or component or a system. And this is its virtual representation. And we see that it has a bidirectional data flow, and it tries to mirror the behavior of that asset either through the it further uses mathematical models. Okay, data driven or mathematical model. It may be a data driven or a mathematical model. Okay, and what makes digital twin so valuable is that it spans the entire life cycle. Life cycle. Okay, so this spans the whole life cycle of the whatever the system or asset we are talking about. And this means that we can use it not only for monitoring, but also for simulation, diagnostics, optimization, and others. So this digital twin, it may help us to do a lot of things. For example, we can do simulation, we can do diagnostics, we can do optimization, we can also do some kind of like some event or prediction. Okay, so for you can add different features for your digital twin. Okay, so as we can see, the data is also two-way. So what is the benefit of having the data is also two-way? Data is two-way. So what is the benefit of this? Benefit of this is that it incorporates the real time, incorporates real time real time operational data. This is one important thing. And it also can talk to or update uh, the real system, the physical system. Okay, it can also update. It's like uh, information or update. Okay, so in summary, what digital twin is doing. Digital twin, in summary, we can say as a summary here, digital twin, DT, I will call this DT because sometimes it is also called data technology. So digital twin is basically enables number one, it enables smart decisions. It further enables faster troubleshooting, and it further makes the overall maintenance very effective. Okay, so effective, even effective, more effective maintenance, more effective maintenance strategy can be defined, and all are driven by, these are all things, all driven by analytics. And basically analytics is driven by, so simply we can say that, AI and data. Okay. Okay, so the next slide is very interesting. In industrial, in analytics, we often describe the process as a journey of uh, four steps. Okay, descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Okay, so let's go through one by one. Descriptive analytics is the most basic form. It answers that what has happened, what has happened. Okay, so in descriptive analytics, and how it does is it basically summarizes the past data. Okay, it summarizes past data. Okay, this is one thing, and it tries to understand trends, and also tries to understand sorry. Okay, so the performance and anomalies. Okay, now in the second thing, which is diagnostic analytics, uh, we are looking for something, why did it happen, anomaly or whatever it is. So this involves identifying the patterns, identify patterns, and then correlating them, root causes, and all of these things are done through some sort of like correlation techniques, using correlation techniques and statistical analysis also, plus statistical analysis. Then comes the third, predictive analytics. In predictive analytics, we are looking to find out what will happen. And so in predictive analytics, what we do is we try to again analyze the data, analyze the historical data, and we try to forecast future outcomes or the risks using the models. So it uses AI models to predict. Okay, and using time series or machine learning models. Then finally, we have prescriptive analytics, where we try to find how can we make it happen or something. So in the predictive analytics, prescriptive analytics, what we do here is uh, in this we have optimization techniques, we have decision uh, rules, and basically what they do is they recommend actions to achieve desired outcomes. Okay, so as we move upward from from this stage to this stage to this stage and then this stage, we have more advanced, and the value addition is increasing here. This is the value addition, or you can say that you are adding the business value. Okay, so for any organization, it is um, for example, the digital transformation, or any sort of digital or any transformation in organization needs that this should be properly followed, and this will make sure that the whatever we do decision making, it will be added value added, what you call transformation structure roadmap. roadmap okay. Okay, so now let's talk about okay, so now we will discuss about uh, a sort of a summary about these four different stages for analytics using this comparative table. In terms of complexity, descriptive analytics is the simplest one, and while the prescriptive analytics is the more advanced, so requiring more data and computation power. So each stage answers a certain question. For example, descriptive um, looks for answers it asks what is the status. Diagnostic will ask us or we do why is it happening. Predictive uh, will ask what's going to happen. This is what we are going to answer in predictive analytics. And prescriptive, in this prescriptive, we try to answer what do I have to do, decision making. So the expected outcomes also vary. In descriptive analytics, we focuses on the KPIs, efficiency, and performance matrices, while the diagnostic gives us some root cause insights and alarms analysis, while the predictive offers probability forecasts and future insights. Okay, how confident we are on something, or what is the probability of happening something. Um, while the prescriptive gives us some kind of like recommendations and decision support. Okay, so if you see, even if you are using the ChatGPT or any of the models, you should be clear about using what kind of AI you are using, what is your question. Okay, it's basically a sort of like it will help us to understand the prompt engineering also using the new AI tools. So we will come back to focus on our current discussion. So in terms of techniques, the descriptive analytics will use rule-based or mathematical formulas, while the diagnostic analytics relies on the formula or domain knowledge. The predictive analytics focuses on utilizing the statistical modeling. It incorporates the regression and machine learning, data-driven. While the prescriptive may involve, it is a larger thing, it may involve the digital twins, even the physical models, deep learning, and even the reinforcement learning. So basically, this table helps us to choose the right approach depending upon the business problem, available data, and the level of decision making. Okay, so this is very important. Let me write these points here. That so this table basically helps us the right approach, uh, which is basically depending on on the business problem, or the business problem, or you can say research problem, uh, and also the available data, and also the level of decision s- decision making needed here. Okay, so this is the most important point here. All right, so let's move to the next slide. Let's begin now with the first stage of the descriptive, which is the descriptive analytics in detail. This is the most basic form of analytics, and the main goal is to answer what happened. Descriptive analytics provides an overview of the system performance or the behavior by basically what it provides is the performance or behavior overview, using the historical records. So, for example, condition-based maintenance, this belongs to the prescriptive stage. We first need to detect the anomalies using the descriptive analytics to decide whether the maintenance is required or not. One important task here is the anomaly detection, and we will discuss this in a little detail in the next slide. And this anomaly detection is basically to find unexpected some unexpected expected patterns or deviations from normal behavior. Okay, so and this process has actually two key steps. The first step is about we monitor the system status, and by collecting the data from the physical devices. And the second thing is we apply the techniques. We apply the appropriate detection techniques based on the operational data. So by identifying early the issues early through descriptive analytics, we can avoid major failure, enhance system reliability, and reduce the maintenance. Okay, so this is important point. Let me write it here also. By identifying by identifying issues, the benefit is we can avoid major failures, we can also enhance system reliability, and we can also reduce maintenance costs. Okay, so these are the three important things we can do. Let's discuss more uh, on the anomaly detection. So basically, there are three type of anomalies. The first one is contextual anomaly, and in this contextual anomaly, you see the pattern is almost same here, here, and almost similar here. The only thing is it is above certain threshold. It is above a certain threshold. So so the abnormality is considered in terms of some contextual data relative to something. The second thing is about point. For example, this data and this data, these are the point anomalies. These are like outliers. They are quite different from the rest of the data. It may be because of some surge. Then we have a collective anomaly. And collective anomaly is a group of data that when taken together signal abnormal behavior like this for an expanded period of time. So these analytics rely on building the data-driven models of the system's operation, normal operation, by and how it is done continuously monitoring the data. Okay, and if whenever something happens against the threshold, okay, it flags some malfunction and failure. So this diagram is basically showing these three patterns. Okay, so anomaly detection does not always rely purely on the data, and in fact we can further categorize them into three types. So the three types can be like the methods. Three most methods are like model based, knowledge based, and the data driven based. Okay, so in model based anomaly detection method, um, we use mathematical simulation. We use mathematical uh, or simulation model to describe how the system is expected to behave, and anomalies are identified by comparing the model's prediction with the actual observation. So the key requirement here is having a high quality. This model should be high quality. Should be high quality. Okay, should be high quality. High quality model, and that can accurately reflect the system's behavior in real time performance. But the problem is practically the systems are quite complex, and for very complex, it is very difficult to establish a complete theoretical model with high fidelity and details. And it often requires deep system knowledge to build one, and we may not be able to capture the all the real world dynamics. So as a result, while the model based is precise, is good, but it is also limited because exact modeling is not feasible in the real environments. So apart from the model-based method, anomaly detection can also be carried out using knowledge-based and data-driven approaches. So in knowledge-based, they function like they are like rule-based expert system. And in fact, in some cases, the expert systems perform better than even the AI-based models. So they mimic the reasoning of the human experts by applying the predefined rules based on their past experience. Okay, so the experts' uh, experience, opinion, and set rules with past experience is valuable. And these are especially useful when a detailed mathematical model is not available. So this is very valuable, very valuable and useful when the detailed mathematical model not available. Okay, and these especially, um, however, this approach performs well for known fault types, and it may occur. Yeah, this is a problem. So this approach uh, works well for known issues or problems, but new or unknown anomalies, it faces challenges. It somehow struggles, and in fact, I don't want to say, but it fails. It may fail. Okay. So on the other side, in the data-driven approach, it has gained these days very popular now, and it is very popular, and because of the popularity is because IoT and plus smart sensors, and these methods actually use uh, large amount of data, historic data. They use a lot of data, historic as well as the real time, both historical plus real time. Okay, and and what they do is they are trying to uncover the hidden patterns. Okay, what they do is they uncover. I mean, their work is very simple. Their target is to uncover all hidden patterns. Okay, and then we can select whatever we like, and to discover this, they use the especially two main methods. They use statistical statistical methods, and they use machine learning methods or techniques. Okay, so the advantage here is that we don't need a first principle model. Instead, we rely on pattern recognition to detect the abnormal systems behavior. This makes the data-driven models ideal. So these are ideal for complex industrial systems or automation systems. Okay, where the traditional modeling is not feasible. Okay, this is an important thing. Where This is an important thing that where traditional modeling is costly. Okay, or not available. All right, so now we are in the second stage, diagnostic analytics, which is one of the most commonly used form. This approach helps us to understand why a problem occurred, why did it happen, and the main aim is why to find the root cause of the problem. And the process typically involves like three key steps. It has three key steps: detect anomalies, discovering the anomalies, and then determining the root cause of the anomalies. So once we detect an anomaly, we need to determine what caused it, and this often relies on human knowledge of uh, the failure modes, and such as the failure mode and the effective analysis. And we may have a large data set of historical failures that will help us. So these insights are often encoded in the form of logical rules linked with symptoms or potential faults, giving the engineer and systems the ability to respond more intelligibly. So actually, we have a training data, and we have some kind of data. Okay, 2 3, and then we give them some labels. Okay, this is good, this is not good, this is not good, and this is, for example, good. Okay, so there might be this is they are so similar, so I would write not good, not good, and this is the good one. So this is how the descriptive diagnostic analytics will work. Okay, so in the third stage, predictive analytics, which focuses on predictive analysis focus on future. Okay, and it talks about what could happen in future. So predictive analytics, it uses regression analysis, regression models. It uses the machine learning. It uses the also the anomaly detection or any other sort of like failure and anomaly detection. Okay, it actually uses this to, and it combines all of them, and its target is to anticipate failures or performance drops before they occur. Okay, so if you find something already happened, so this is not predictive analytics. So this is especially important, and because of this nature, it is especially important in IIoT, because in industry we want the industry want to prevent uh, costly downtimes. Okay, so this is the most important, one of the most important things. Okay, so particularly a valuable subclass of predictive analytics can be prognostic analytics. This refers to establishing the time of failure and the risk of degradation, and for example, how much life is remaining. This is very important, especially in terms of for the industry, finding out the remaining life, useful life of something, some equipment or something. And RUL basically it helps us how many cycles or hours are left before a component should be replaced. Uh, so this prediction is based on the major damage levels, historical pattern, and even the real-time operating data. So in essence, predictive and prognostic analytics allow industries to transition from reactive to proactive maintenance. Okay, so I should write it like predictive and prognostic analytics analytics help uh, help industries to in making a transition from reactive to proactive maintenance, which is very valuable, and the benefit is saving costs, uh, improve what you call safety, and also the asset life improves. Right. Okay, so this is slide 21. We will complete two more slides to complete this module. Okay, so in this here we have, while the predictive analytics is powerful, it is also sensitive to uncertainties. Predictive analytics is sensitive to uncertainties. Uncertainties. And that's why we are looking at the probability density function here in this slide. The data actually we collect from the sensor or equipment, it may be the data basically, whatever the data is, data will be noisy. It will have some noise. It may incomplete. Okay. It will have some problem. Okay. So poor calibration, it is common thing. Okay. So data will have problems. Data will have problems. Uncertainty, you can say that. And collectively, we collectively call all of these things as we model um, we model uncertainty. Okay, we model all of these as uncertainty. Uh, for example, when we are estimating the real remaining useful life, we just don't want to a single number. We also want to understand so there is something called confidence. Okay, for example, you tell me, okay, this valve will remain, the remaining life is 50%. So how much confident are you? How confident are you? Okay, on this value. So we need to understand how confident we are in any prediction. Okay, we we need to know the confidence dense in our predictive analytics or predicted value, right? So to handle this thing, we talk about the probability density function. PDF in simple call. So the PDF gives us a range of possible outcomes and shows the likelihood of each outcome occurring. So a narrow, uh, see the narrow, okay, so a narrow PDF indicates high confidence. And uh, so if the PDF is like here, this is very high. It has very small. So this one is high confidence. But if it is spreading like this one, so this is large uncertainty. And this is any value, for example, this value, if it is coming all near this one, so it is this one. So we have a good number of values coming to the same point or similar. So this is the high confidence. High confidence. Okay. And here the value can occur on anywhere here. So this is low confidence. Okay. So here the values will occur. Okay. In a small, you see this one. So this one has no uncertainty. It has a small uncertainty, and this one has a large uncertainty. So this is what we will be requiring, and this is what we don't like. Okay. This is low confidence. This mentions low confidence. All right. So uncertainty is critical for turning the predictive analytics in. So it is okay, whatever you have done to uh, the uncertainty uncertainty uh, builds the action, okay, and it mentions the trust in predicted value. Okay, right. So this is the fourth one. We now move to the most advanced stage of analytics, predictive prescriptive analytics. This level does not just predict what will happen; it goes a step further to answer the question how should we respond to these potential future events. So predictive prescriptive analytics it offers offers recommendations and actionable strategies and decision pathways, right? So this is what predictive analytics offer us, and it tells us what action to take, when to take them, and why they are necessary based on the predictive outcomes and also the risk evaluation. A widely adapted application of this industrial IoT is basically the condition-based maintenance, shortly called CBM. Instead of replacing the parts on a fixed schedule or failure, CBM uses the sensor data to monitor the actual condition. Okay, so it will monitor actual data, and then based on that they will schedule maintenance. Okay, instead of like replacing every time or a fixed schedule, instead of fixed schedule, instead of fixed schedule. Okay, so if the performance degradation or anomalies are detected, CBM triggers actions such as repairs, replacements before the major failure occurs. So this reduces the downtime, improves the equipment longevity, and all while maintaining the continuous production. Okay, so this is the most interesting thing. Okay, so this is the last slide in this video lecture. After that, we will have a new topic on the examples of this. So one of the key decision-making question in the condition-based maintenance is in CBM is should we replace or repair this component now or take the risk and let it continue operating? So CBM helps answer this by continuously monitoring about any asset condition and recommends the actions only when needed rather than just based on the physical or fixed schedule. So this diagram is illustrating how CBM fits into the broader landscape of maintenance. So on one side we have like corrective maintenance, which responds to failure. So this corrective is something happened and it responds to failure. And on the other side, we have the preventive maintenance. This includes the predetermined actions, which are like schedules, and also the condition-based actions that are done on the request based on the real-time data. Okay, this is based on real-time data. Okay, so the CBM enables smarter decision making by allowing interventions in just in time, just in time, and not too early, not too early, and not too late. Okay, so the decisions, these are the smart decision making, and it is because of the uh, condition based monitoring. Okay, so this enables smart decision making, and we can do just in time decision, which is not too late, not too early. based on the actual performance data. All right. So I will stop this slide here, and we will continue the next topic on in the new lecture. Thank you very much.